So those who have joined the class may give their attendance in the chat box. I repeat, those who have joined the class may give their attendance in the chat box. Fine. Can you tell me whether my slides are visible or not? Please say whether my slides are
Yes, sir.
visible or not.
Visible. Visible.
Okay, okay, fine, fine, fine. Okay, good afternoon to all of you. So, before starting today's class, let me give you a brief recap of what we have covered in the last class. In the last class, we have started our discussion with the design of riveted joints. We have seen different types of rivet joints as well as the different terminologies which are used in rivet joint. We have seen what are the materials available in order to make a rivet, as well as we have seen the five basic failure criteria of a rivet joint. In today's class, what we will do is we will be finding out the expressions of or different ways by which a rivet can fail. So mathematical expressions we will try to find out, and then we will be solving some previous year's gate problems. Okay. So let us discuss about the strength equations. What is strength equations? Strength equations are those equations which a designer need to keep in mind while designing a rivet joint. If you want to define or if you want to determine the strength of a rivet joint, how you can determine it? For that, firstly, you need to define what do you mean by the term called strength of rivet joint. Strength of rivet joint is defined as the force that the joint can withstand without causing failure. I repeat, strength of a rivet joint is defined as the force that the joint can withstand without causing failure. When the operating force acting on the joint exceeds the this force, that means the force which is operating on this joint exceeds the maximum force, then the failure of the rivet joint takes place. First of all, what is strength of the rivet joint? Strength of the rivet joint is defined as the force that the joint can withstand without failure. Before failure, the load which the joint can withstand, that is termed as strength of the rivet joint. When the operating force means when the rivet is in operation, during that time the force acting on the rivet joint, if that force exceeds the maximum permissible force, then the failure of the rivet joint will take place. Normally, strength of the rivet joint is calculated on the basis of three different types of rivet failure. They are shear failure of rivet, tensile failure of the plate between the rivets, and crushing failure of the plate. I repeat, mainly the strength of the rivet is determined by taking into considerations of three basic type of failure, and those failures are shear failure of rivet, Tensile
Tensile
failure
failure.
between the rivets and crushing failure of the plate. Is it clear?
Yes, sir. Clear. Clear.
Okay. So first of all, let us see how shear failure of the rivet takes place. If you see, this is what? This is nothing. The figure A and B is nothing but the front view of rivet joint. This is a single rivet joint. Both are single riveted joint. If you see the first figure, it is nothing but single riveted lap joint. And what is second figure? Second figure is nothing but single riveted double strap butt joint. Fine. So how the shear failure of the rivet will occur? So if I assume that for figure A, this is plate A and this is plate B, then on plate A, if you apply load, if you apply an axial load along this direction, parallel to the cross sectional area of the rivet, and on plate B, on the other hand, if you apply an axial load in negative x direction, parallel to the cross sectional area of the rivet, then at the rivet cross section, what will happen? The rivet will break by the help of shear. Is it clear? Hello.
Yes, sir. Clear.
Fine. The same thing also happens in case of butt rivet joint. See, this is your plate A. Assume that this is your plate B. Both the plate you have but both the plate are connected to each other by butt joint with the help of rivets, and in order to keep the or in order to provide sufficient strength to the rivet, what we have applied, we have used these two cover plate. Now what will happen if you try on plate B, on this particular side, if you apply an axial load parallel to the cross sectional area, and on plate A, on the other hand, this is that other hand, if you apply an axial load in negative x direction parallel to cross sectional area, then this is the rivet cross section. The failure of the rivet will take place by the help of shear. That means this failure, where it is taking place, it is taking place between the or at the junction of the plate and the strap. This is your strap, this is your plate, this is your strap. At the junction of the plate and strap, the shear failure is taking place in this direct side also as well as in this side also. Is it clear? Any doubt so far? Hello?
No, sir.
Hello?
Yes,
Okay,
sir.
fine. So if I consider, say, PS is what? PS is the shear strength of the rivet when shear failure of the rivet is occurring. Then in that case, the shear strength of the rivet is given by, we know that shear stress tau is given by shear strength divided by cross sectional area, and I can see that the cross sectional area of the plate is what? This is nothing but, since here I will take the cross sectional area of the rivet, not the plate, because the rivet is undergoing failure, and the cross sectional area of the rivet will be pi by 4 into d square. So it will become pi by 4 into d square, and what is d? D is nothing but the shank diameter of rivet. And what is shank? I know that this is a rivet, Fine. This is a rivet. So this portion is called the shank. So this is that shank diameter of the rivet. And what is tau? Tau is permissible shear stress of the rivet material in Newton per millimeter square. And what is PS? PS is the shear strength or shear resistance of the rivet per pitch length. And the equation which we will use to design the rivet when it is undergoing a shear failure is PS is equal to pi by 4 d square into tau. Is it clear? Any doubts so far?
No, sir. Yes.
Okay, now there may be a case that more than one rivet joint is used to join two or more plates. So if more than one rivet joint is used, then the given formula or the given formula for the strength of the rivet joint in shear, we can write it as PS is equal to pi by 4 d square tau into n, where what is n? N is nothing but the number of rivets per pitch length. For a double riveted joint, value of n is 2. For a triple riveted joint, value of n is 3, and so on. Similarly, for a say, for if 7 rivets you have used in order to join two particular plates, then the value of n will be 7. Is it clear to you? Any doubt? Hello.
No, sir. No doubt.
And
So it is
in
for only for double as well as triple.
double, triple, or more than that, because
Okay.
this n factor is coming. No, what is n? N is nothing but number of rivets per pitch length.
Number of
If
rivets.
number of rivet is 1 per pitch length, then value of n is 1. If number of rivets you have used is 2 per pitch length, then value of n is 2, and so on.
Two. Yes.
So
Yes. Yes.
this is valid in case of lap joints, in case of riveted lap joints. But in case of butt joints, that is in case of, for example, if you see the second figure is what? It is single riveted double strap butt joint. It is single riveted double strap butt joint. Fine. So in case of double strap single riveted butt joint, the rivets are subjected to double shear. If you see this diagram carefully, this second diagram, this is what? If you see this second diagram carefully, it is nothing but a rivet joint, that too a butt rivet joint, because we have joined both the two plates like this. We have joined both the two plates like this, and in order to keep the strength, what we have did here, we have used one cover plate, and here we have used one cover plate, and this cover plate has been joined with the main plate by the help of rivet by the help of rivet. So that means if you see this particular plate is joined by one as well as one, total two cover plate by a single rivet. Similarly, the second plate is joined with one cover plate as well as with the second cover plate by a single rivet. Fine. So that's why I am calling it as, it is a single riveted double strap butt joint. But if you see here, shearing is happening two times. See, this is the first shear of the rivet. This is the second shear of the rivet. So for this particular case, if you want to write down the shear strength of rivet, the shear strength of rivet for this particular case becomes PS is equal to 2. Why 2? Because double shearing is occurring. See, this is first shear and this is second shear. 2 times of the remaining formula is same. That is pi by 4 d square tau into n. Where n is your again the number of rivets per pitch length. If number of rivets is 2 per pitch length, value of n will be 2. If number of rivets per pitch length is 3, value of n will be 3, and so on. So did you understood the difference? Means this for first figure, if I talk about this first figure, then this formula is valid. This formula is valid for this figure, and for second figure this particular formula is valid because shearing is happening 2 times. Because for this particular figure, that is for double strap single riveted butt joint, 2 times shear is happening. So the shear strength will be 2 times of pi by 4 d square tau into n. Is it clear? Any doubts so
Yes, sir.
far?
No, sir. Clear. Clear.
Okay. So let me erase all these things and then I will move forward. Okay, I think Shaikat has joined. Shaikat, can you please give your attendance in the chat box? You haven't given your attendance. Please give your attendance in the chat box. Okay. So this is about shear strength of rivet. Next is tensile strength of the plate between rivet. That means rivet can fail due to tensile strength. So that means if you see this first figure is what? This is the top view. This is the top view of the single riveted lap joint, and this is the front view. In the earlier case, we have taken or we have kept both the two plates like this, and then we have made a rivet like this, and then we have applied load in this way. Fine. But this time what we are doing, we are keeping this particular rivet joint in a vertical position. This is the vertical position of the rivet joint. Assume that T is what? T is the thickness of the plate. TT is the thickness of plate, and thickness will be same whether you consider plate A or you consider plate B. Fine. So due to application of tensile load, due to application of tensile load, now observe the top view clearly. So if you apply a tensile load PT in this direction and PT in the opposite direction, fine. So what will happen? The rivet will fail in between the diameter of the drilled hole. That means if I want to find out the strength of the rivet joint, how I can find out? That is sigma T. Strength of the rivet joint is given by tensile strength of the rivet joint, that is PT divided by area. Resisting area is which one? This particular portion. This is your resisting area. Fine. That is, this is your resisting area. This will be what? This will be nothing but I know that the center to center distance of the diameter of the two consecutive dia of the hole of rivet in a single row is nothing but pitch. So this is your pitch P, and if I take this particular length, which particular length? That is, this will be how much? This will be my d by 2, and this will be my d by 2. So this particular length will be how much? That is P minus d by 2 minus d by 2. So it will be P minus d by 2 minus d by 2. Minus d by 2 minus d by 2 is equal to how much? It is nothing but equal to P minus d. Yes or no? This minus d by 2 and minus d
Yes,
by
sir.
2 will
Yes,
be
sir.
minus d. So the tensile strength of the plate between the rivet becomes, that is sigma t, that is tensile stress is equal to tensile strength pt divided by that cross sectional area, that is this p minus d by 2 minus d by 2 into thickness of the plate t, into thickness of the plate. So that means minus d by 2 minus d by 2 is minus d, so it will be p minus d into T. So I can write PT is equal to how much? P minus D into T into sigma T. That means this particular expression. PT is equal to P minus D into T into sigma T. Where what is PT? PT is the tensile resistance of the plate per pitch length in Newton. What is small p? Small p is pitch of the rivets, and I know that from the terminology I know that pitch of the rivet is how much? It is nothing but equal to 3 times the diameter of the rivet. 3d. And what is T? T is the thickness of the plate in mm. What is sigma T? Sigma T is your permissible tensile stress of the plate in Newton per millimeter square. So when a rivet is failing by tensile strength, then I will use this equation, that is Pt equal to P minus D into T into sigma T, to calculate the tensile strength which the rivet has resistant in the plate. Is it clear? Any doubt so far? Any doubt so far? Hello.
No, no, sir. No, sir.
Okay. Next and the last failure by which we can determine the strength of the rivet joint, that is crushing strength of the plate. That is crushing strength of the plate. If you remember in the last class I have told you what is crushing strength of the plate. Due to crushing strength, what will happen? The rivet, this rivet hole, that is this rivet hole will become wider, like this, like this. If you see this diagram, fine, here you can see that the rivet hole is becoming, that is this portion of the hole, it is becoming wider. After some time period of time, it will be like this, then it will be like this, then it will be like this, and ultimately when it reaches to the end of the plate, then the failure takes place. Is it clear? Any doubt? Hello. Hello. Please respond whether it is clear or not.
Yes, sir. Yes, sir. Visible, visible, sir.
Okay. So this type of failure, that is the crushing, this type of crushing strength resisted by the plate. This type of failure occurs when the compressive stress between the shank of the rivet and the plate exceeds the yield strength in compression. That means crushing strength sigma c is given by crushing strength, and crushing stress sigma c is what? It is equal to crushing strength pc divided by resisting area of the plate, and that resisting area of the plate will be dia of the rivet hole d into t, thickness of the plate. So pc becomes sigma c into T into D. And if more than one number of rivets if you have used in any joint, then you have to multiply the factor n also. What is n? N is the number of rivets per pitch length. So the crushing strength of the crushing strength or crushing resistance of the plate is given by the expression Pc is equal to dt sigma c into n, where Pc is crushing resistance of the plate per pitch length. Sigma C is the permissible compressive stress of the plate material in Newton per mm square. N is the number of rivet per pitch length. D is the diameter of the rivet. And T is the thickness of the plate. Is it clear? Any doubt so far? Hello? Hello? Please respond whether the part which I have just now I have talked, it is clear or not. Okay, since nobody is responding, so I will assume that everything is clear to all of you. Next.
Yes, sir. Clear.
Okay. Next is once you have found out the crushing strength of the plate, tensile strength of the plate between the rivets, and the shear strength of the rivet.
Yes, yes.
Next is I need to find out the efficiency of the joint, how efficient my rivet joint is. That is, what is the efficiency of the rivet joint? So first of all, let us define what is efficiency of rivet joint. Efficiency of a rivet joint is defined as the ratio of strength of the rivet joint to the strength of the unriveted solid plate. That means what is your efficiency of a rivet joint is equal to strength of the rivet joint, strength of the rivet joint when you have put the rivet in order to join the plates, in order to join both the plates, divided by strength of the joint when the rivet has not been placed in between the two plates which you need to join. Okay, so this is the definition of rivet joint. So strength of the rivet joint. So eta is what? It is nothing but strength of the rivet joint divided by strength of the unriveted solid plate. Strength of the rivet joint is given by the least value of PT, PS, and PC that we have determined from the strength equations. That means, first of all,
जिसका कम वैल्यू आएगा वही होगा.
yes, in order to find out the efficiency of the rivet joint, what you need to find out? First, you need to find out the shear strength of the rivet joint using the correct formula. Then you need to find out the tensile strength of the tensile resistance of the plate per pitch length by using the correct formula. And then you have to
Then
find
crushing
out
PC.
crushing strength of the plate by using the correct formula. Out of these three strengths, that means out of PC, PT and PS. Which value you have to take? The minimum value. Which
Which
value you
value?
need to take? You need to take the least value or the minimum value. So that value divided by strength of the unriveted solid plate, and the strength of the unriveted solid plate is given by strength P is equal to PT sigma T. P is nothing but pitch, because we know that sigma T is what? Sigma T is equal to P divided by cross sectional area. Cross sectional area was, if rivet was there, then the cross sectional area was P minus D into T. Since rivet is not present, so this D we will ignore ignore, and the formula becomes P is equal to PT sigma T. Capital P is equal to small p into T into sigma T. What is this small p? Small p is pitch. So once you have found out the strength of the unriveted solid plate, then I know that the efficiency of the rivet joint is given by the expression called least of either PT or PS or PC divided by strength of the unriveted solid plate, that is PT sigma T. With this expression, you can find out the efficiency of the rivet.
Efficiency of the rivet joint.
Your rivet joint, how much your rivet joint is efficient during the
Yes, yes.
working conditions. Is it clear? Any
Yes,
doubt?
sir. Clear. No, sir.
Okay. So with this, we have completed this strength portion. Now let us solve one previous year gate problem, which has been it was asked in the year 2013 from these particular topics. Okay, so let us
Yes, sir.
solve that question. The question is a single riveted lap joint. It is a figure is given to you. This is a figure. Fine. This is one plate. This is another plate. Thickness of both the plate is T, and in order to join and both the plate by lap joint we have joined both the plates by one single rivet. W is what? W is the width of the plate, and P is the tensile load acting on the plate. Next, what has been told? That a single riveted lap joint of two similar plates is shown in the figure below, has following geometrical and material details. Width of the plate is 200 mm. That means this width value is given. That is how much? 200 mm. Thickness of the plate is 5 mm. That means this thickness T is given to you. That is how much? 5 mm. And diameter of the rivet hole 11 millimeter. That means diameter of the rivet hole, this rivet hole diameter is given to you, that is 11 mm. Diameter of the rivet is 10 mm. Now there is a difference between diameter of rivet hole and diameter of rivet. What is the difference? This is the difference. I know that this is my rivet. This is my rivet, and this portion is called shank portion of rivet. So this is
Yes, sir.
the
Shank diameter.
diameter of rivet. This diameter of rivet is nothing but the shank diameter. But how
Yes, sir.
you will insert this rivet in between the plate? You can only insert, say you want to insert over here. Then what you need to do? You need to drill hole over here. You
Yes,
need to
hole will be
drill
there.
one hole. Over here you need to drill one hole. In between the hole, this rivet will pass. That diameter of hole is given. That diameter of hole is given to you. See, it is given diameter of rivet hole is 11 mm. That means this hole diameter is 11 mm and the diameter of rivet D is 10 mm. This is the point where you can make mistake. Fine. Is it clear? Any doubts?
No,
Difference
sir.
between
Yeah,
dia of
clear.
the rivet
You
and
put
dia
me
of the
clear.
rivet hood. Okay.
Yeah,
Allowable
clear.
tensile stress of the plate given to you is 200 megapascal. That means sigma P. T is given. Let it be sigma T or sigma P. Allowable shear stress of the rivet sigma S or tau.
Sigma S, but tau S is given.
Tau, it is 100 megapascal, and allowable bearing stress of the rivet sigma C, that is crushing stress, it
Sigma
is
C is even 150.
megapascal. So the first question what they are asking is, if the rivet is to be designed to avoid crushing failure, what is the maximum permissible load P in kilonewton? Since the rivet is to be designed in order to avoid crushing failure, I know
So we have
that
to use the crushing equation.
this equation I need to use. Fine, that is
Yes,
P
yes.
equal to D into T into sigma C into N.
T into
Fine.
N.
Sigma C is given in the problem. T is given in the problem. N will be equal to 1 because only, I think we have used only one rivet. Yes. N is equal to
Yes.
1. Only one rivet we
1.
have used. And tell me the value of D. Which D I will take? I will take this dia of the rivet hole 11 mm, or I will take the dia of the rivet as 10 mm. Which D I will take? In this expression of PC, everything is given. T, sigma, C, D is also given. But which D I will take? Whether I will take the dia of the rivet or I will take the dia of the rivet hole.
I think die of the rivets.
Yes, I need to take the dia of the rivet.
The rivet.
Fine. So if you, so that means dia of the rivet means which expression? That is dr. Dr is nothing
Yeah.
but the dia of the rivet 10 mm. And since you
Yes.
can see that three holes you have been drilled, three holes you have been drilled in order to, for three holes you have been drilled in order to join both the plate via rivet joint. So value of n will be equal to number of hole drilled, that is 3. So if you
Three.
use this expression, everything is given to you. N is given to you. D is your dia of the rivet hole. T is given in the
Yes. T
problem.
is given. Sigma C is given.
Problem. If you solve this expression, you will get the value of the, which value you will get the value of the maximum permissible load in crushing
That
failure.
is PC
And that
value
is
I will get.
to be 22,500 Newton, or in kilonewton if I talk, it is 22.5 kilonewton. That means option number C.
Yes.
Okay.
Yes.
Very easy problem. First, only the
Yes.
thing is that you need to remember the formula, and that too, in that formula, you have to remember D is what, N is what, T is what. Fine. And accordingly, you have to substitute.
Yes.
Similarly,
Yes.
the second problem is, if the plates are to be designed to avoid tearing failure. Tearing failure means tensile failure.
Tensile. Tensile failure.
And what will be the maximum permissible load P in kilonewton? We know the
Then I
expression.
have to use a tensile equation for
Yes,
failure.
now we have seen that is sigma T is equal to tensile load P upon cross
P.
sectional area of the rivet. So cross sectional
Yes.
area of the rivet will be this width
With
minus
W
pitch of the rivet,
minus
and this
pitch.
pitch is equal to 3 times of diameter. But 3 times of
Yes.
which diameter? Dia of the rivet or dia of the hole?
I think die of the whole.
Yes, because we, how we are getting the pitch, because the definition of pitch is, it is the center distance, it is the center distance between two consecutive diameter center, it is the central distance between two consecutive dia of the hole drilled in a single row of
Yes, sir.
rivet. Fine. So this P is what? It is 3 times of dia of the hole. So dia of the hole is given to you. That is 11 mm. Width is also given. I think it is given in the problem 200 mm. So this 200 minus 3 times of dia of the hole is 11, into thickness is given 5, into sigma t is given in the problem 200. If you solve this expression, you will get the tensile load which the rivet can bear without causing tearing failure is 167 kilonewton, which is option number C. Okay? Any doubt? Hello? Any doubt? Hello?
No, sir. No, sir.
Fine. So it was a very simple problem, but the thing is that you should know the correct formula, which formula you have to apply to find out the values, and in that formula you should know what is n, what is p, what is small d, what is t. Then easily you can find out the unknown things. Okay. So with this, we will end today's lecture over here only. In the next class, we will solve some more previous year's gate problems which has came in the which have came for this rivet joint. Okay. Till then, thank you.
Yes, sir. Thank you. Thank you, sir.
Okay. Welcome.